Three.
Assalamualaikum to the lecturers and my fellow friends. Today, we gonna present about our electronic group project about odometer. Before that, I'm gonna introduce our group member, Ashraf bin Abdul Majid as a leader, Muhammad Nazrul Adil bin Azhar, Muhammad Imran Sufian bin Muhammad, which is me, Shafiz Zurhadri bin Zulkifli. The introduction of odometer. In this study, the problem statement is how sensor is used to determine vehicle speed in odometer. Then the objective of the study is to determine vehicle speed and provide simulation of actual application in vehicle. The scope of the study is limit to gear ratio of 1:1 and limits and the speed is to 5,000 rpm. In this study, we gonna specialize in Suzuki engines. What is odometer? Odometer is an instrument that indicates distance traveled by an automobile, truck or other vehicles. Type of odometer, there are various type of the odometer. One of the type of the odometer is mechanical odometer, turned by a flexible cable made from a tightly wound spring.
Okay, for our methodology, firstly, we gonna install software which is including Arduino and MATLAB. We need to install Arduino because we will use Arduino hardware, which is it only need Arduino software to convert the data, and we use MATLAB in order to collect all the data. Next, for experimental setup, there are 5 components included. Firstly, DC power supply, variable resistor, electric motor, Arduino, and laptop. DC power supply we use to supply the voltage around 5 volt, and variable resistor is an light pedal in car we use to press pedal. Electric motor, we use electric motor is lightly flywheel, rotation of flywheel, which is the rotation of electric motor. We will assume it as flywheel around 5,000 rpm. For Arduino, it will convert signal transmit by tachometer, and it will collect data in form of MATLAB data collection. And after that, we will use MATLAB in simulating block, which is we need to convert the output from Arduino into motor speed rpm. Then using simulating block, the motor speed is calibrated. The speed is entered, the motor speed is converted to speed. Firstly, we transmit data from Arduino. We need to calibrate first, which is we will use linear equation. After that, we will convert that from the formula equation. We will convert the calibrate one, and we will use powertrain formula for the ratio. And after that, we will get the answer in form of kilometer per hour.
Assalamualaikum. Okay, for the experiment, we have 2 type of experiment. For the first one, experiment 1. When during experiment 1, we take the values of voltage when engine speed in RPM. The maximum RPM that we use is 5,000 RPM. This is because the limit of the motor that we use is just about 5,000 RPM. We start from 0 RPM and increment by 5,000 RPM until 500 RPM until 5,000 RPM. After that, by according to the engine speed, we will get the value of voltage, and then we plot the graph. We plot the graph of engine speed versus versus voltage. Okay, from the graph we get the linear relationship for the graph. According to the graph, we will get the equation. From the equation is used for the simulation block, which is act as the calibration control. The value of equation that we get from the graph, we will use to calibrate to make sure that the value that we get is same for the both at the simulation block. The next step is we need to get the speed of vehicle in kilometer per hour. Before we get the speed in kilometer per hour, we get the value in RPM first. After that, we need to convert the speed of vehicle in kilometer per hour. In order to get to convert the value, we use gear ratio 1:1 of Suzuki Swift car. According to the formula, we insert the formula into the simulation block in order to change the value of engine speed from RPM to kilometer per hour. According to the value, we plot the graph of engine speed, RPM versus kilometer per hour. For experiment 2, we use the same circuit as in experiment 1, but in experiment 2, we adjust the variable resistor that act as the throttle. We adjust until the maximum value, and then we decrease the value until 0. From this experiment, we get the time domain for the engine to reach the RPM 5000 RPM, and until we reduce the RPM to 0. So
Bismillahirrahmanirrahim. Next, I will explain to you about the result and discussion about what we have gained from overall projects. First, I would like to show you the result of our experiment. First, when this is the graph when RPM versus voltage, where you can see as the voltage is increased, the value of the RPM also increase. What we can gain from this experiment, that we can conclude that if the voltage applied to the odometer, we can get higher value of rotation. This is same as the actual application where we supply more power to the engine, there will be a higher rotation of the engine that we can achieve. Next, this is the second graph for the experiment, where as we show, if we get higher value of RPM rotation, for example 1000 rotation per minute, 2000 rotation per minute, the value of the movement of the vehicle speed is increased. For example, if you can see, for 1000 RPM, it achieves 20 km and above for its vehicle speed. And as you can see, the overall of the graph, when the rotation per minute of the vehicle is increased, the vehicle speed also increase. Next, I will show. Okay, this is the lagging time for the overall experiment, where you can see it takes around 15 seconds at least 15 seconds to achieve from 0 to 5000 RPM. What it shows us that the vehicle speed need a shorter time to accelerate, around 15 seconds from 0 to 5000 RPM, and it need the same amount, almost the same amount, to decrease it to decelerate from 5000 RPM to 0 RPM. Okay, for the speed and the time is also the same, almost the same result as before, where the speed from 0 to the 130, it need around 15, at least 15 seconds to accelerate from 0 to 130. This show that when the vehicle moving or decelerate, it need around need time for at least 10 seconds and above. Okay, that's all for our slide. Thank you very much.